Today we're going to learn section 10.6, the law of cosines. Last time we looked at the law of sines. Today we're going to look at the law of cosines. And by using the two of them together, law of sines and law of cosines, we should be able to figure out the sides and angles of any triangle given part of the information. So the law of cosines we use for side angle side and side triangles. And then we're going to look at a formula called Heron's formula. It dates back to ancient Greece that allows us to find the area of an SSS, side triangle. So when we have a non-right triangle for which we do not know, we do not have the side or angle pair, but we do know two sides and an angle between them, or all three sides, so side angle side or side, we use the law of cosines. And we'll define that on the next slide here. So the law of cosines, it's a little bit tricky, but you'll notice that for finding sides, here we have a squared, b squared, and c squared. So a squared is equal to side b squared plus side c squared minus 2bc, so it's going to be the same as these two, times cosine of the angle that we're trying to find across. So here's angle A, and we're trying to figure out side A, and we know side B and C. And angle A, we can find out side A using this formula. And the other ones are similar. Now, if we need to find the angle, and we have all three sides, so for finding sides, that's a side angle side case. For finding angles, that would be the side case. We would use this formula. Cosine of A is going to be b squared plus c squared minus a squared, okay, divided by 2 times b times c. I know that's a lot to figure out. And then to find angle A, we would need to take the inverse cosine of this. So when you plug that into your calculator, make sure that you get all the pieces together and make sure that you calculate it correctly. Okay? So let's take a look at an example. So I've got an angle A, which is 35 degrees. Side B and side is 7 and side C is 9. Okay, so we're going to use the law of cosines for side angle side. What does that look like? Okay, so we're going to find the opposite side from the angle that we have. So we're going to use this formula. A squared is equal to b squared plus c squared minus 2bc cosine A. So when we're calculating this on our calculator, make sure that we multiply all of this together. Okay, and then so it's going to be b squared plus c squared minus all of this multiplied together. Well, we know what b is, we know what c is, okay, and we know what angle A is. So if I plug this all into my calculator, I'm going to get a squared is equal to 26.7867, and we're going to take the positive square root of that, which is approximately 5.176. Okay, so now we have side A. We need to find the rest of it. Well, I can use my law of sines to find side angle B. So I'm going to say sine of B is to 7 as sine of A is to side A now. And doing a little bit of cross multiplication, a little bit of math, I can figure out that B is going to be the inverse sine of this thing here, 7 times sine 35 degrees divided by 5.176. And if I plug that into my calculator correctly, and again, I suggest you practice this to make sure that you're doing it right, you should get 50.869 degrees. So now I have angle A, I have angle B, I have side A, B, and C. The only thing left to figure out is C. And we can figure out C just simply by subtracting A and B from 180. So C turns out to be 94.131 degrees. So let's compare. Angle C is the largest angle. It's across from the longest side. Angle A is the smallest. It's across from the smallest side, and B is in the middle. So that makes sense. So I'll give you a couple seconds to jot that down. And as always, you can come back and revisit these videos. Okay, we'll continue on. Here's another example. Now I've got side, side, side. I've got side A, B, and C given there. And what can we do with that? Well, we can use the side, side, side law of cosine. So we can figure out what angle A is, or we could figure out what angle B is over here, or angle C. Doesn't matter which one we do first. But we'll use A first because we can. So cosine of A is equal to B squared plus C squared minus A squared divided by 2BC. So all I have to do is plug in all my values. So cosine A is equal to 23 squared plus 14 squared minus 25 squared divided by 2 times 23 times 14. And I would get a decimal number that looks like 0.155, something, something, something. And then take the inverse cosine of that, again, making sure that I'm in degree mode. And it comes out to be approximately 81.067 degrees. So now I have one angle. Now that I have one angle, I could use law of sines, or I could use law of cosines again. It doesn't matter which one I use to find the other angle. Here, I got a little cut off there, but I think you can see it. I'm going to use law of sines. So sine of B is to 23, as sine of C, which we just calculated, is to side C. To find angle B, I'm going to take the inverse sine of this whole thing, 23 times sine of C divided by 25. Take all of that, and it equals approximately 65.346 degrees. Now to find angle C, I'm going to simply subtract A and B from 180, and that gives me 33.587. If I look at my final tallies here, A is my largest angle. It's across from the largest side. C is my smallest angle, across from the smallest side. And B is in the middle. So I'll give you a couple seconds to get those notes down. Again, I suggest practice doing these on your calculator because it's very easy to make a mistake when you're trying to calculate some of these inverse signs and you're multiplying things and dividing things. And so practice, practice, practice to make sure that you can calculate these correctly on your calculator. All right, we'll continue on. All right, so here's some applications of law of cosines. So scientists can use a set of footprints to calculate an organism's step angle, which is a measure of walking efficiency. The closer the step angle is to 180 degrees, the more efficient the organism walks. This is the diagram of a set of footprints for a dinosaur. Find the step angle B over here. Okay, so we've got three sides. We want to find angle B. We don't really care what A and C are. We could figure those out if we wanted to, but we can use the law of cosines to find angle B. It's going to be A squared plus C squared minus little b squared, all divided by 2AC. Using my calculator to calculate that, and a lot of times you're going to want to put these extra set of parentheses in when you're doing it with your calculator because It's easy to make a mistake. But if I did that, I would figure out that the step angle is 127.317 degrees. And you can try that on your calculator. All right, let's take a look at another example. A pilot is flying from Houston to Oklahoma City, a distance of 396 miles. To avoid a thunderstorm, the pilot flies 28 degrees off the direct route for a distance of 175 miles. He then makes a turn and flies straight on to Oklahoma City. To the nearest mile, how much farther than the direct route was a route taken by the pilot? That's a little bit confusing, so let's make a sketch of it to figure out where he's going. He's in here at Houston and he wants to fly directly to Oklahoma City, which would be 396 miles. But he can't do that because of the thunderstorm. So he flies 175 miles off course at a 28-degree angle until he can get around the thunderstorm. And then he flies directly to Oklahoma City. And we're going to figure out what that is. Okay, so we've got B and we've got side C and we've got angle A, so we can use the law of cosines. A squared equals B squared plus C squared minus 2 BC times cosine of angle A. And if I plug that into my calculator correctly, I come up with A is approximately 65,064.463. Take the square root of that. It's approximately 255.077. So this is obviously not quite to scale here. Maybe it is, but this is 100. No, not quite, because this is 175 miles. If that's 255, doesn't look quite right. But that's okay. But now we just have to add these two together and see how much further it is than 396. So A plus C is equal to approximately 430.077. Subtract 396, and it gives us approximately 34.077 miles further. All right. The last thing we're going to look at today is Heron's formula. Again, this goes back to ancient Greek times, so the Greek mathematicians figured out that the area of a triangle, if I know the three sides, I can use this formula, the square root of s times s minus a times s minus b times s minus c. Well, what is s? S stands for semi-perimeter. It means half of the perimeter. S in and of itself really isn't all that useful, except for we're going to plug it into this formula, but it means half of the perimeter. Well, what's the perimeter? A plus B plus C. That would be all the way around the triangle. The semi-perimeter would be half of that. So 1/2 A plus B plus C. Now we're going to plug that into the formula with the given sides to figure out the area. So we can only use this if we know that all three sides. Okay? So S equals 1/2 A plus B plus C is equal to 51 divided by 2, or 25.5. Now we're going to take that 25.5 and plug it into that first formula there. So area is equal to the square root of 25.5 times 25.5 minus 11 times 25.5 minus 19 times 25.5 minus 21. And if I calculate that correctly on my calculator, it comes out to be approximately the square root of 10,815 and point something, something, something. And if I take the square root of that, it comes out to be approximately 104 square units. So another way to find the area of a triangle. So again, try these on your calculator to make sure that you know how to do them. All right, so here's another practical example. I've got a intersection of three streets here with a triangle in the middle, and I want to see how much area is in the middle. And maybe I want to plant a garden or something in that little triangle. So if A is 170 yards and B is 240 yards and C is 350 yards, I really don't care what the angles are, but I do want to know what the area is. So the semi-perimeter, 170 plus 350 plus 240 divided by 2 is equal to 380. Now, the area then is 380 times 380 minus 170 times 380 minus 350 times 380 minus 240. And if I plugged it into my calculator correctly, it's approximately 18,307.376 square yards. So quite a bit of area. Okay. And I believe, yes, that's all we're going to do for today. So there is your homework listed, and you can get started on that now. Here's some Alex suggestions. I do highly suggest that you keep up with the Alex to help you with some of these problems. So that is all we're going to do for today.